Okay, now here, I'm going to go ahead and I need to find the value of the derivative at each relative extrema. Now, your extremas occur when you have a horizontal tangent. So what I have to do here is I have to take the derivative. Now, before I take the derivative, I'm going to go ahead and I'm just going to distribute the 9. So that's going to be a 9x squared minus 27 over x cubed. I need to do the quotient rule. So I'm going to set the derivative. I'm going to do the quotient rule. Low. Now d high, the derivative at the top is just going to be an 18x. Subtract high, which is going to be 9x squared minus 27 times d low. D low is going to be a 3x squared all over the denominator square. I'm going to distribute this. So that's going to be an 18x to the 4th power. Now, right here, when I distribute, this is going to be a 9 times 3, which is a 27. X squared gives me x to the 4th. Now, when you're distributing here, don't forget you have a negative and a negative, which gives you a positive. And then 27 times 3 is going to be 81. So that's actually going to be a positive 81. Because remember, that's going to be a positive 27. However, because the negative is going to be a negative. Right here, that's going to be a negative 81. However, a negative makes that a positive 81. And then right here, x to the 3rd raised to the 2nd power, I'm multiplying that. That's going to be x to the 6th power. Go ahead and combine like terms. Those are like terms right there. So 18 minus 27 is going to be a negative 9x to the 4 plus 81x squared over x to the 6. That can actually be reduced because right here you have 4 x's, here you have 2 x's, and here I have 6 x's. So I can reduce each of these by 2. So I'm going to reduce each by 2. So I have a negative 9x squared plus 81 over x to the 4th. Now, here's the derivative. I need to set the derivative equal to 0. Set the derivative equal to 0 and solve. Now that's going to give me my horizontal tangents, which happen to be your maxes and your mins. So now here, I'm going to set 0 equal to negative 9x squared plus 81 over x to the 4th. Now, if you multiply by x to the 4th to both sides, that does nothing for me. So technically what you're doing is because x to the 4th times 0 is still 0. You're just technically solving the top. You're just solving the top. So now here, what I'm going to do is I'm going to go ahead and I'm going to move the 9x over there. So I have a 9x squared equals 81. Divide both sides by 9. And when I take the square root, x is equal to 3, plus or minus 3. So right here, I have 2 answers. I have an x equals a positive 3 and an x equals a negative 3. So let's go back. From the very beginning, I took the function and I took the derivative. Then I set the derivative equal to 0. But I'm not done yet. I now need to plug the x values into the original problem, into f of x, to see if the y values is a max or a min. A high number is a max, a low number is a min. So here's the function. I'm going to plug it into there. I'm going to plug in a positive 3 and a negative 3. So let's do the negative 3 first. That's going to be 9 times negative 3 squared minus 27 over negative 3 to the 3rd power. Right here, order of operations says to do exponents first. I'm just going to type this in my calculator. I have alpha y equals 9 parentheses negative 3 squared minus 27 in the denominator. I have a parenthesis negative 3 raised to the 3rd power. So that answers a negative 2. So that is when x is -3, y is -2. Now I'm going to plug in 3. -9 times 3 squared minus 27 over 3 to the third power. Actually, that's +9. Alpha y equals 9 times 3 squared minus 27 over 3 to the third power, and that equals a +2. So here x is 3, y is 2. All right, I need to actually look at the graph here. I'm gonna have to actually graph them and look at them and then tell, are they gonna be relative maxes, mins, absolute max, or absolute min? Actually, this problem just says relative maxes and mins. Okay, so now I'm gonna graph it, and it's alpha y equals, the numerator was 9x squared. This is the original function, minus 27 over x to the third power. So this is what the graph looks like. So at 1, 2, 3, it goes up to 2. That was this point. But if you notice, it looks like this. And then this point right here is -3, -1, -2, -3, -2. And then if we look at our graph, it looks like this. So this point right here is a relative max because it's a high point. It's not an absolute, it's a relative max. So this one is a relative max. This one right here, because it's on the bottom, it's a relative min. So make sure that you set the derivative equal to 0. There is no absolute here because I don't have a closed interval. Note that the derivative either is 0 or does not exist. The x value are called critical points. Critical points. Now, this is the definition of a critical point. We're going to let f be defined at c if the derivative at c equals 0, or if f is not differentiable, meaning you can't take the derivative at c, then c is a critical number of f. So let's say c looked like this. Because that's a peak, this is not differentiable at c. You cannot take the derivative there because it's like a teeter-totter, okay? So it's not differentiable. So the derivative at c does not exist. Does not exist, DNE. If this is your graph, well, guess what? I have a horizontal tangent. the derivative at c equals 0. I have a horizontal tangent. This one has a critical point. Relative extremas only occur at critical points. Now remember, an extrema, you can only have one absolute max, one absolute min. If f has a relative minimum or relative maximum at x equals c, then c is a critical number of f. Now these are going to be the steps to finding the extremas. The first step is to find the critical number. Critical numbers of f in the interval from a to b. How do you do that? You set the derivative equal to 0. You set the derivative equal to 0. Next, you have to evaluate f at each of those critical points. In the open interval from a to b. So you have to plug in f of c. You're not done though, because you can only have relative extremas on closed intervals. Well, guess what? From the very beginning, your endpoints, those can be extremas. Like right here, that endpoint was an extrema. So now I have to plug in my endpoints. So now I want to evaluate f at each endpoint. So now you're plugging in f of a and plug in f of b. Plug in f of a and f of b. Lastly, the least of these values, so the least y value is the minimum, and the greatest is the maximum. We're going to end with an example now. Find the extrema of f of x equals 3x to the 4 minus 4x cubed on the interval -1 to 2. So step number 1 says to find the critical points. The critical points is when the derivative equals 0. So here's my function. My function says f of x equals 3x to the 4 minus 4x cubed. I need to find the derivative here. So the derivative here is going to be a 12x cubed minus 12x squared. I have to set the derivative equal to 0. So I'm going to set that equal to 0. Now this can factor. That has a GCF of 12x. If I factor out a 12x here, I'm left with x minus, 12x squared. I'm left with 12x minus 1. So now if I set this equal to 0, I get x equals 0. If I set this equal to 0, I get x equals 1. So these are our critical points, okay? These are called our critical points. These are possible absolute maximum and possible absolute minimums. So now the second step says to evaluate f at each of the critical points. So now I have to plug in f of 0 and f of 1 into the original function. So f of 0 is 3 times 0 to the 4th minus 4 times 0 cubed. Oh, that's easy. That's just a 0. I'm going to plug in a 1 now. F of 1 equals 3 times 1 to the 4th minus 4 times 1 cubed. Well, that's a 1. That's a 1. I'm left with 3 minus 4, which is a negative 1. So these right here are my critical points. Step number 3 says evaluate now at the endpoint. So now I have to plug in a negative 1 and a positive 2. So now I'm going to plug in f of negative 1. That's 3 times negative 1 to the 4th minus 4 times negative 1 to the 3rd. Negative 1 to the 4th, that's a 1. That's a negative 1, which makes that a positive 4. So when I plug all this in, I get a positive 7. Now I have to also plug in the endpoint 2. 3 times 2 to the 4th minus 4 times 2 to the 3rd. When I plug all this in, I get a 16. Now these are my endpoints. And then the last step says the least of the values. Look at the y values. The least one is going to be the absolute min. So right here, that is the absolute min because it's the smallest. And the largest of these numbers is this one. That's going to be the absolute max. So you have an absolute minimum at x is 1, y is negative 1. And we have an absolute maximum at x is 2, y is 16. Now, one thing I forgot to mention is, remember, you're looking on an interval. These numbers, your critical numbers, have to be on the interval. If the critical numbers are not in this interval, then you don't even have to do it because it's not in the interval, so you're not even looking at that part of your graph. All right, and that concludes our notes.